Before we go into software or modeling, it is important to understand why fire and smoke simulation is critical. In most fire incidents, smoke, not flames, is the primary cause of injuries and fatalities. Smoke affects visibility, temperature, and toxicity, making evacuation difficult. Traditional fire safety design often relies on simplified assumptions and code-based rules. However, these methods cannot predict how smoke will actually move inside a building. Fire CFD simulation helps engineers visualize real smoke behavior, evaluate safety performance, and design more effective fire protection systems. Fire and smoke simulation is widely used across different types of buildings and infrastructure. Typical applications include basement car parking, where smoke extraction is critical, and staircase pressurization systems, which are essential for safe evacuation. These air simulations are also used in shopping malls, atriums, warehouses, tunnels, industrial buildings, airports, and high rise structures. In many large or complex projects, fire CFD is no longer optional, it is a mandatory requirement for performance based fire design and approvals. Traditional rule-based fire design methods are useful, but they have clear limitations. They are based on simplified, conservative assumptions and do not represent real fire scenarios accurately. Such methods cannot capture smoke stratification, temperature gradients, or local visibility conditions. When dealing with complex geometries or unconventional designs, rule-based methods often fail. This is where CFD simulation bridges the gap between simplified design and real physical behavior. Fire CFD simulation is a numerical method used to simulate fire growth and smoke movement, heat transfer, and airflow. It solves the fundamental governing equations of mass, momentum, energy, and species transport. Instead of assuming uniform conditions, CFD predicts spatial and time-dependent behavior of fire and smoke. This allows engineers to evaluate temperature, visibility, smoke layer height, and the effectiveness of ventilation systems. The Fire Dynamics Simulator, commonly known as FDS, is a specialized CFD solver developed by NIST in the United States. It is one of the most widely accepted tools for fire and smoke simulation worldwide. FDS is open source, extensively validated, and used by fire engineers, consultants, and researchers globally. It is particularly well suited for low speed buoyancy driven flows, which are typical in fire scenarios. While FDS is powerful, it is traditionally input file based, which can be challenging for beginners. Pyrosim acts as a graphical user interface for FDS, allowing users to create geometry, define fires, and set up simulations visually. Pyrosim significantly reduces the learning curve and helps beginners focus on engineering logic rather than syntax. In this course, Pyrosim will be used as the primary modeling tool while FDS will run the calculations in the background. SmokeView is the visualization tool used to post-process FDS results. It allows engineers to visualize the smoke spread, temperature contours, fire growth, and visibility. SmokeView is extremely important because simulation results are meaningful only when they are correctly interpreted. In this course, you will learn how to use SmokeView to understand and explain simulation outcomes clearly. Let us briefly understand the complete workflow of a fire simulation project. First, geometry is created using Pyrosim. Next, the computational mesh and domain are defined. Then, fire sources and ventilation systems are modeled. The simulation is executed using FDS, and finally, results are visualized and analyzed using SmokeView. This structured workflow will be followed consistently throughout this course. This course is designed for mechanical engineers, fire engineers, HVAC and MEP professionals, and fire safety consultants. It is also suitable for engineering students and professionals who are new to fire simulation. No prior experience with Pyrosim or FDS is required. The focus is on building strong fundamentals, making it an ideal starting point. After completing this course, you will understand the basic physics of fire and smoke movement. You will be able to create simple fire models in Pyrosim, define fire sources and ventilation, and run FDS simulations confidently. You will also learn how to visualize results and prepare a basic fire simulation report. These skills form the foundation for more advanced fire engineering analysis. The course starts with fundamental concepts and software setup. We then move into geometry creation, mesh setup, fire modeling, and ventilation. Finally, we will run a complete beginner level project and interpret the results. Each section builds logically on the previous one, ensuring a smooth learning curve. With this understanding of the context and importance of fire simulation, we are now ready to begin the technical journey. In the next section, we will start with FDS and smoke U, followed by a detailed walkthrough of the Pyrosim interface. Let's get started.